Hello, welcome to Apex Hours. My name is Julian Duque. I am a lead developer advocate at Salesforce, and today we are going to be talking about elastic computing without limits with Salesforce Functions. Remember that since Salesforce is a publicly traded company, please don't make any financial decisions based on the information that is contained on this presentation. Salesforce Functions is not yet publicly available, so hold on until it is become available for you. Let's see, what are we going to be covering today? First, we are going to be talking about Salesforce Functions and why it matters to us as Salesforce developers. Then let's do an introduction about Salesforce Functions and how can we start learning and use them today, even though they are not generally available. Then we are going to be learning about the interfaces. How can we start writing functions in both JavaScript using the Node.js runtime and Java, and how can we integrate these two programming languages with Salesforce data. And it's going to be pretty much all the big part of this presentation, it is a demo. I'm going to be showing you how can you start creating a new project with new functions from scratch using the Salesforce developer tools. Well, what is a function? A function is a single purpose, on-demand, short-lived microservice without complex infrastructure. So let's untangle a little bit more this definition. So normally when we are going to write a function, this means we are going to leverage computing capabilities that are external to Salesforce core to solve a specific problem or a specific operation. This is why we say that a function is single purpose. On demand means that depending of the traffic or the amount of users that need to consume this single purpose function, this function is going to scale elastically, is going to automatically adapt to the demand, is going to automatically adapt to the amount of traffic that it's coming to this specific service. Short-lived means that this is not a long-running service. This is not a web application that is constantly running, sometimes idle, waiting for a customer or a user to consume it. Similar to services that are deployed to a platform like Heroku. And we say that it is a microservice because of what we said at the beginning. It is a single purpose service. We are not going to be adding a lot of different logic into a function. We are going to try to create functions that are very specific to a problem we are trying to solve. And the last thing, without complex infrastructure, is that we don't care about how the function is deployed, where it is running, how to configure it. Everything is taken care for us. The Salesforce team is going to take care of scaling the function, running the function on their own infrastructure, so you don't need to invest on a DevOps team or on any operations related activities to maintain this function running. We are going to be taking care of this for you. So let's introduce a Salesforce Functions. A functions scale elastically on trusted infrastructure, and this is one of the most important things. Scale elastically is what I said before, is going to adapt depending on the demand. If we are receiving a lot of traffic, the function is going to scale and it's going to add more computational resources to be able to manage all this traffic. If we are not receiving any traffic, the function is pretty much going to shut down until more traffic is going to come. And it's running on trusted infrastructure. This means that it is running within the Salesforce trusted boundary. So we don't need to set up any authentication or authorization resources to be able to access Salesforce data from a function. It can let you innovate with flexibility. pretty much deliver business value faster with native access to Salesforce data and languages such as Node.js and Java. You will be able to extend Salesforce applications using Node.js, Java, but not only the languages, also their full ecosystem. So you will be able to use NPM libraries or Maven dependencies in your own Node.js and Java projects. And lets you deliver connected digital experiences, so you can empower your team to build integrated solutions with low code and pro code. You will be able to connect a low code flow with a function or a Lightning Web Controller component with a function as well. This is going to give you way more capabilities to increase and extend your Salesforce applications. Why they are great? As I mentioned, the first thing is they scale elastically. Second, you are staying on platform. You don't need to go to a different cloud provider to be able to achieve elastic computing. And third, it can bring you more people to work with you. Pretty much, you can extend Salesforce data with elastic build inclusively with all of your developer talent using open languages and tools that scale on demand. So you will be able to bring JavaScript and Node.js developers and also Java developers to work with you in your Salesforce projects. When to use a function? So let's say that we have a certain org activity, and if we are doing an operation and we need more processing power, that means we are hitting the governor limits. In that case, we need a function. Since the idea to use functions is when we are going to have a compute heavy or an already asynchronous operation. So for example, this is going to be good for query quote lines, query products and price rules, calculate prices, update quotes, access external database, etc. But if I don't need more processing power and I'm within the governor and Apex limits, I will continue to use Apex. Apex is still the core language for the Salesforce core platform. But if my logic doesn't need to run within the transaction, but still I'm reaching closer to my governor limits, I might use a function to be able to execute these operations outside the core platform and connect and integrate with the data I already have. Now let's take a look how a function looks like, what is the anatomy of a function, how can we start learning about a functions today, and how can we integrate a function with Salesforce data. So the best way to start learning about Salesforce Functions is through the Functions Recipe Sample application. You can go to the Trailhead Apps GitHub repository, search for functions-recipes, and here is going to be a full Salesforce application using different functions, examples, and you will learn how to integrate both Lightning Web Components, Flow, and Apex with functions. So this is going to be your guide to learning Salesforce Functions. You can run these examples locally, and later when you have access to an organization with functions, you will be able to deploy this project and run it on the Salesforce platform. But you can still run it locally using all the Salesforce developers tools today. You are going to find realistic examples using Java, JavaScript, and also TypeScript. And we, the developer advocates, are going to continue adding more examples to this project. So initially, we are going to be delivering experience to build functions in Node.js using JavaScript and TypeScript and in Java. So let's take a look at the anatomy of a function in JavaScript. Each JavaScript function exports a async function. This is where all of the work is done. So we are just exporting one asynchronous function in JavaScript. This is why it's called a Salesforce function. This function has access to three different objects: the event, the context, and the logger. The event contains the payload that was passed into the function. This is going to be the input of the function. The context allows access to an authenticated org and the Salesforce SDK. And the logger helps you log information right from your function to the Salesforce Functions log that you can later connect to a log drain. Similarly to JS, a Java function pretty much is a class that implements a Salesforce Functions interface. This Salesforce Function interface is what we call in Java a bifunction. It uses two different parameters. The first parameter is going to specify the type of the input, and the second parameter is going to specify the type of the output. These are going to be plain old Java objects that you can specify with the fields and methods that you need specifically for your function. And the Salesforce function runtime is going to take care of the serialization of these two types. Then you will need to implement the apply method. And the apply method, it's where the magic happens. It's where you are going to execute the logic of the function. So this apply method has access to the event, which is an instance of the invocation event class, and the context, which is an instance of the context class. And similarly to JS, the event contains the payload, which is going to be represented by that input class, and the context has access to the org and the Salesforce SDK. You can also invoke functions from Apex in both synchronously and asynchronously. First, you will need to get the function reference using functions.function class. With that namespace, you will be able to get the function by name. Then you will need to invoke the function using the function.invoke method. This will return a function invocation. This object contains the response. If there is an error, it's going to have an error message and an error code. If it is a success, it's going to return a JSON string response. It also receives as a payload a JSON string. So you will need to do the serialization of a JSON input parameter and a JSON output parameter. An asynchronous invocation is going to be very similarly. You will need to get the function reference, and the function invocation will receive a new callback as a second parameter of the invocation. A callback in this case is going to be a class that implements the functions that function callback interface, and you will need to implement the handle response method. The handle response method receives an instance of the function invocation, and here in this method is where you are going to handle the logic of the invocation. Let's take a look at the Salesforce SDK for Node.js functions. If you want to take a look at the Salesforce SDK for Java functions, I will give you the link to the documentation at the end of the presentation. So pretty much the same methods are going to be available in both languages. So how to interact with the Salesforce SDK? You interact with the Salesforce SDK through the context object. So the Salesforce SDK, it's the gateway to your Salesforce data and organization information through a number of interfaces. So through the context, you will have access to the org information, the data API, the unit of work, which is a pattern to create multiple record operations in one single batch. You will have access also to the user object and many more. For example, the org interface would give you information about the authenticated org that your function is getting access to. You can get the ID, the API version, the base URL and domain URL. You will have access also to the authenticated token in case you might want to create API calls to other Salesforce APIs, for example, the metadata or bulk API. The user interface will give you information about the user that is executing that function. You will get the ID, the user ID that is running this function, and the username as well. The data API interface, it lets you create, query, update, and delete Salesforce data. If you want to run a SQL query, if you want to create a new record, or if you want to perform any other CRUD operations, you will use the data API. Here in the code, you are seeing that we are performing a join query using SQL, and then we are getting the result as a JSON object. You can also create an object. In this example, we are creating a new account with the name field, and this name field, we are getting it from the payload. And later, when I do the demo, I'm going to be showing you an example. How can we create an account from the CLI, and we'll confirm that account has been created on a Salesforce org. The unit of work interface is the one I mentioned that lets you have multiple CRUD operations within a single transaction. If one of those operations fails, pretty much the whole transaction is going to be rolled back. So first, we will need to create a new unit of work object, and with that unit of work object, we are going to be creating multiple operations. So we register those operations. In this example, we are registering a new create operation of type account, and we receive something called the reference ID. That reference ID is the ID we are going to be using for future operations to create relationships. In the next step, we are creating a contact, and we are using the previous created account ID to relation the contact and the account. And then we are creating a case, and we are using both the account ID and the contact ID to create a relation between this case and the two previous created objects. At the end, we are going to submit all of these three operations within one single transaction by committing the unit of work. This will perform one API operation instead of multiple API operations, which is going to be way more performant. Now it is time for the demo. For this demo, I'm going to be using the Salesforce Developers tools to create a new project, and this project will have functions created from the CLI or from Visual Studio Code. I'm going to be using the new SF command. The SF command is part of the CLI unification effort that we are doing here at Salesforce to have one just CLI to rule them all. In order to start working with Salesforce Functions, we need to start from a Salesforce project. In order to create a Salesforce project, I'm going to be using the new SF command. The SF command is coming on the new CLI unification that will be released in the coming month. How can we generate a project? Let's run SF generate project and give it a name. This is going to create a folder with all of the necessary files that are needed to push code into a Salesforce organization. And in this same project is where we are going to be generating the functions using the same CLI command. This project can be opened in Visual Studio using the same Salesforce Developers tools available for Visual Studio Code. So let's take a look at this project and the files that has been created. So first we have the sfdx project.json, which is the definition of the project. One important field here that you will need to have is the name. And why we need a name? Because with this name, we are going to be referencing the functions. when we are going to be calling the functions from Apex, we need to have the name of the project and the name of the function. So this name is very important. Also, you can notice here that I am using the latest API version. I am using Winter 22 because Salesforce Functions, it's planned to be available for Winter 22. Then, if we are going to be using functions on a Salesforce project, we need to enable the functions feature in our organization. If you're going to be working on a Scratch org, first, you will need to have a Salesforce organization with functions enabled. And second, you will need to add the functions feature to the Scratch org configuration. So let's go to the Scratch org configuration and add the functions feature. Perfect, I am ready to start working with functions. What are we going to do first is work with functions locally. I am not going to be deploying functions yet. I am going to be running and invoking the functions locally here in my computer. For that, you will need to have Docker installed to be able to run the functions in your own computer. Then you will need to start creating or generating the functions. For that, you can use either Visual Studio Code or the CLI. And I'm going to be showing you the two approaches. First, let's create a function using Visual Studio Code. I'm going to be using the command palette using Command-Shift-P or Control-Shift-P, which is going to be on Windows, depending on the operating system you have. And here I have the sfdx create function command. I'm going to be creating a function. Let's enter a name for this function. I'm going to be calling this function query.js. As the name says or implies, we are going to be using JavaScript for the first function. The second step is to pick up the language. So our language here is going to be JavaScript. And that's it. It is running this command. It is creating a new folder called functions. And inside that folder, we have a new query.js project. This new query.js project, it's a Node.js project that has functions enabled. So as you can see, the input is going to be a JavaScript function that exports a asynchronous function that receives three parameters: the event, the context, and the logger. Remember that we already saw this in the presentation on the function anatomy. And here in the output, it is telling you that first, you will need to enable functions in your dev hub. And second, you will need to add functions to the features list in your Scratch org. So we already have that. Now let's start working locally with this function. I'm showing you the local experience, and then I'm going to be showing you how to deploy the function. So every project that is created by Visual Studio Code or the CLI is going to be a specific project for that language. So if I go to functions query.js, this is going to be a regular Node.js project. So it's going to have a package.json with dependencies, and it's going to have tests that you can run as well. So if I run npm install, it's going to fetch all of the dependencies. And if I run npm test, it's going to run the test for that specific function. And as you can see here, the function tests have passed. You can go to the test folder and take a look at the unit test that has been created for that specific function. What does this function do? This function, it's using the data API interface that I mentioned in the presentation to query the org. And it's using SQL to return the ID and the name from the account object. Then it is returning that results to the invoker, to the caller. And I'm also using the logger to log different informations while I am executing the function. For example, here I am logging the input, which is going to come from the payload. The payload comes into this data property within the event. And here I am just logging the stringified version of the results. Like we are taking the results from the query call and we are returning that as a JSON here. So let's run this function locally and let's then invoke it. So by running the function, what we are doing is simulating that the function is running on a compute environment, is running on a, let's say, virtual machine. And invoking the function is we are sending an input and expecting an output. How can we start the function from Visual Studio Code? The same. Opening the command palette using Command-Shift-P and selecting a start function. And this is going to pretty much start the function. And it needs to take a little bit of time because it's going to build the function, it's going to put the function in a container image, and it's going to be running the function locally in Docker. So this might take some time while download, build, and install. So meanwhile this is running, I'm going to be showing you from the CLI how can you also generate a function. So let's go to the CLI. In this case, let's go to the terminal. We are going to the project FX demo. And here in the FX demo folder, let's run a self-generate function. We are going to give a name. Let's say query Java. It's going to be the same function, but written in Java. And we need to select a language, which is going to be Java. Let's run the command. And let's do it again to create the same function using TypeScript. So this is creating the function using Java. Now you can see that it created a Java function in that specific folder. And then we are going to generate a function called query_ts, which is going to be a TypeScript function. And that's it. This is the way you can create functions locally, and these functions can be deployed then into a compute environment that is going to be connected to a Salesforce organization. So let's get back to Visual Studio and take a look at the two other folders. So we have the two other folders here, Query Java and Query_ts. Query Java, as you have guessed, it is a Java project. And Query_ts, as you have guessed, it is a TypeScript project. So let's take a look at the Java project. One other file that I forgot to mention that is very important is the project TOML. The project TOML is the metadata definition for the function. Here you can find the ID of the function. This is going to be the ID used when we are going to invoke the function from Apex. And it also has a description if you want to specify like what is the main purpose of this function. Since we are taking a look at a Java project, you might find similar files like the pom.xml. Here is where you can specify the different Java dependencies using Maven. In a Node.js project like the one we are running locally, you might find the package.json, which is going to be the similar file. And this one is also the file where you are going to specify the dependencies for this specific function. So one of the main advantages of functions is that you can also use the NPM and Maven ecosystems to extend the functionality of the function. And the Java function has other files that we are going to be taking a look later. And why later? Because now I got a message that my function is running. and I want to show you what's going to happen next. So here we run the SFDX start function from Visual Studio Code, and now my function is running locally. Remember that we are running the query.js function. So here in query.js, I'm going to be creating a new file. Let's call payload.json. This is going to be the entry point for the function. And my function doesn't need any input right now, because if you see, this function is just returning an account. It doesn't need an input. It is just printing out the input to the logs, but it doesn't do any operation with the input. And then from here, we can invoke the function. We can click here on the invoke command, and now we are invoking the function. You can see that we are calling the function, and now I have a result. Since I don't have any account, pretty much it is returning 0 records. We don't have any account on my organization. Let's change that. Let's create an account using JavaScript. So we are going to be changing this example a little bit. First, let's create an account by receiving a name. So I need an account name, and that account name is coming from the payload. So I am sending the name from the payload. So I'm getting it from the event data account name. And then I am going to be creating a account here. So I am going to use the create method. This is going to be of type account, and the fields are going to be name, account name. And that's it. That's how can we create an account from a function. But there is one thing that I am missing. First, I have not created that Scratch org. So pretty much I am not connected to a specific Salesforce org. This is why I might not get any records here. And I don't have the permissions to do it. So let's do that. Let's create an Scratch org. So this project is going to be connected to the Scratch org, and then apply the permission sets. I already have a permission set for the accounts. Here I created a functions permission set file that is giving me access to account object. And then let's go ahead and run the Scratch org creation. So here I am creating a new Scratch org with the functions future enable. I am setting an alias fx demo org and setting that as a default Scratch org for my project. And then after it gets created, I am going to be assigning the permission sets. So I'm going to be pushing the code and then assigning the permission sets. So successfully created the Scratch org. Let's do a for source push. I'm going to be forcing to override the functions permission set that it's already created. Sorry, with F. Now it is deploying the permission set. Perfect. And now I can assign it. So now my user is going to have access to the account. Fantastic. Perfect. So I updated my code. Remember, I am creating a new account. Let's send the account name as the payload. This is JSON, so account name, this is going to be Apex hours. And let's restart the function. So I'm going to be stopping the function. Now I'm going to be showing you how to run a function from the CLI. First, you will need to go to the project folder. So let's go to Functions, Query.js. This is going to be the function that we wanna start. Then, with SF, you are going to execute SF run function start. And this is going to be starting the function as we saw before, but from the CLI. Now let's wait until the function is built and run locally so we can start testing it and invoking it. Now we can see that the Query.js function is running again, so we can go ahead and invoke it, but this time we are going to be invoking it from the CLI with the newly created payload. So let's go back to Visual Studio Code, let's go to the terminal, and see how can we invoke this using, again, the CLI. We can invoke it by running sf run function. Then we specify an URL. This case is going to be the local URL where the function is running. As you can see, the function is running on port 8080. And then I'm specifying the payload. And the payload is going to be the file payload.json. Let's run the function and let's take a look at the result. We are expecting that this function is going to create a new account in my organization. And you can see it returned a new ID. That ID needs to belong to a specific account. We are going to be checking if the account has been created by going through the query Java function. But first, let's stop this Query.js function, go to the query Java. Here we have the query Java project. Let's run the test by using the Maven wrapper. Instead of npm test, which is used for both JavaScript and TypeScript projects, for Java projects, we are going to be using the Maven wrapper to run the tests. Because here we are using the Maven wrapper to run the test to see if our function is running properly, and we can see no issues, the tests are passing. And then I'm going to be starting the function. So it is the same command that we are going to be using to start a Java or JavaScript function. The function's runtime environment is going to detect the language you are using to build the function and is going to start the compute environment for you. So as you can see here right now, it is building the query Java function. Meanwhile, this is building and installing the full Java runtime. Let's take a look at the source code. So let's go to the query Java folder, and here we are going to be navigating to the source folder. We have two different projects here. We have the main source code and the test source code. So let's open the main source code. We have the main file for the Java function, and we have other types that we have defined to be working with the function. So remember, a Java function, it is a class that implements the Salesforce function interface, that it's a by function that uses two different types, an input and an output. So input is any plain old Java object, and output is the same. It is a plain old Java object. We take care of the serialization for you. We are going to be taking this input and this object and converting it to JSON and vice versa. So you don't need to worry about serialization in Java. So here we have the function, the implementation, what it does is gets the list of records by using the data API. So we are going to use the same similar interface. We are getting the data API from the organization. We are running the so-called query. We are getting the records. Here we have the list of records. And now we are creating a new list of accounts. From each record, we are getting a field. So we are getting the ID and the name. And then we are creating a new account object. And this account object, again, it is a plain old Java object that contains the two properties, the ID and the name. And that's pretty much it. What we are returning is a new instance of the function output object, which contains a list of accounts. And this is what we are going to be returning while using this specific example. So when we invoke this function, we are going to be expecting a list of accounts, including the Apex hours that we created in the previous example. So let's take a look and see if the function is running. Perfect timing, the Java function is running. Now we can invoke it. So let's go ahead, go to the query Java folder and run the invocation. So again, it is the same localhost URL, and this case, the payload is going to be empty because we are not expecting any input here. We are just expecting an output. Let's execute the invocation to my Java function. And I should get the account I created previously and maybe other accounts that are part of that Scratch org. And there you go. We have the Apex hours account that we created on our previous exercise and the sample account that comes with this Scratch org. So now we have two functions that are interacting with a Salesforce organization, and we are using open source technologies like JavaScript and Java to interact with it. So now that we have these running here, let's deploy these functions into a compute environment. So what we need to do first is to log in into the compute environment. So functions are going to be running within platform. As I told you before, it's going to be on the trusted environment, but you will need to have a specific account that has access to functions. So let me go to the terminal. I'm going to be stopping the local execution, and I'm going to be logging in to the functions environment. So let's run sf login functions. So here, I'm going to be opening a browser. Let me open here the browser window to log into the functions feature. Let's click on login. And I will need to log in with a different username because I have like a ton of different accounts. Let's use a custom domain. I'm going to be using the org I already have enabled with functions. So let me copy that URL. Perfect. And my credentials. Perfect. I have here the credentials. So now I am opening my functions trial organization. I am authenticating. I am now logged in. And after I'm logged in, I will be able to create a compute environment. So how can I create a compute environment? Or what is a compute environment? The compute environment is the space where the functions are going to be running. This space is going to be special because it has different limits than the governor limits. It's the elastic computing space that I mentioned before, where functions are going to scale depending on the traffic they are getting, and it's the one that it's capable to run these functions in different languages. So I will need to create a space that is going to be connected to my org so I can deploy the functions in there. So let's run sf emb create compute to create my new compute environment, and I'm going to be connecting my environment with the demo org that I created, and I'm going to be creating an alias for my environment. So let's create the compute environment. This will take some time until it's created. And after it's created, I will be able to deploy. So in order to deploy, I will need to have the functions in a Git project. And I will need to commit all of my project first in order to do a success deploy. So I have my project here on Git. I need to add the files. I'm going to do a new commit. Deploy functions to compute environment. Perfect. And now I'm going to be using the CLI to deploy. So let's do a sf project deploy functions to my org, to the compute environment that it's available for the specific org I want to use. Oh, I made a mistake. It is not project deploy. It is just deploy. So sf deploy functions to my org. Okay, now it is pushing the changes to the functions compute environment. This is going to take all of the function source code. It is going to put it into the compute environment, and the compute environment is going to do the same process it is doing locally. It's going to build some container images specific to those languages, and at the end, I am going to have references to call the functions from the organization. So when this is deployed, I am going to be able to show you how can we invoke one of those functions from Apex. Now that you can see that all of my functions has been deployed to the compute environment, we can see the references here. We have the fxdemo query Java, fxdemo query JS, and fxdemo query TS. And remember that it was very important to have specify a project name, because this is going to be the reference I'm going to be using to invoke these functions from Apex. So now I'm going to be opening this org, and I'm going to be invoking the function from Apex using the developer console to make it easier. So let's wait until this Scratch org is open. Perfect, and let's go and open the developer console. So let's go ahead, open the developer console. And let me increase the zoom. Fantastic. So let's open the debug. I'm going to be running some anonymous Apex, but you get the idea. You will be able to create an Apex class, have this code snippet into an Apex class, and that Apex class being invoked by a flow or a Lightning Web component, or you can also use the asynchronous code to run a function within an Apex trigger as well. So let's execute the Apex code that will invoke that function. So we are going to be listing the records. We are going to be listing the accounts. By that, we are going to use let's use the query Java function that we saw before, or we can use the query TypeScript, which is going to be doing the same. So let's get an instance of the function. Let's call it fn by calling function get and passing a function's name. This needs to be fxdemo query Java. Then we need a function invocation. So let's get a function invocation, and it's going to be function invoke, and let's pass an empty payload. And then let's copy the following code I have here, and I'm going to be explaining to you a little bit to make it easier. I'm having the invocation. So first I am checking if I have any error. If I have any error, I'm going to be printing out the error, or I am getting the response, which is going to be a success. So this is going to be a success, and printing out the success. So let's execute this and open the log to see if my function is being executed by Apex. So let's open my function. I am executing the query Java function. And here we can see that we have some output. Here we can see that we have Apex hours and sample accounts for entitlements. And the most interesting thing is that even though we are doing a query, this query is not being counted into this Apex execution because it is the function that is doing that execution for us. And that's pretty much it. Let's change this to invoke the query TS function instead, and we might get the same result. This is going to be executing TypeScript instead of Java, and we might get a very similar response. So here we can see that even though the output is a little bit different because of the serialization between Java and TypeScript, we are getting the same results. And if we wanted to create a new account, let's open the query.js that creates an account. And in the payload, we are going to pass account name. And this is going to be Apex hours debug. It's going to be a new account created from the debug console. So let's run execute. We are now creating a new account. Let's see if we have an ID. Perfect, we have an ID, so the account was created, and we can go ahead and run the query Java without a payload to see the new created account. Let's open the log of this new execution. And now we can see Apex hours debug created from a function connected to a Salesforce org and being invoked by an Apex snippet. So this is pretty much what I wanted to show you about Salesforce Functions. There is way more features and way more things to cover, but I am expecting to come back to the channel and share more about Salesforce Functions with you. Next time, I want to show you the function recipes project that we created with a lot of different examples and how are we integrating those examples with Salesforce Flow, with Lightning Web Components, and how we are creating like a more integrated solution between a Salesforce application and different functions that are being deployed into a compute environment. Well, I hope you liked this session about Salesforce Functions and you are as excited as I am with this new project. Stay tuned because GA is coming soon, so you will be able to use this technology in your own projects. Stay connected with us as the Salesforce developers advocate. You can go to the new developer website at developer.salesforce.com. You can connect with us on Twitter on @SalesforceDevs, and you can also join us on our different social media channels, especially also our YouTube channels. You can find us with Salesforce developers. Go ahead, subscribe, and consume all of the different content that we are also creating for you, our Salesforce developers. And I want to thank you and thanks Amit and all of the team behind Apex Hours for inviting me to talk about something I'm really excited about, which is Salesforce Functions. Remember, follow Apex Hours. The hashtag is Salesforce Apex Hours. You can follow @Apex Hours on Twitter. Remember the website and the different social channel links. Thank you very much for having me. And remember, I am Julian Duque, your lead developer advocate at Salesforce, and I will be talking a lot about Salesforce Functions and Heroku in the future. So see you on the next time. Bye-bye.